In this video, I am going to walk you through the solution to a common type of multivariable exercise, which is finding the directional derivative of a function. Okay? This is my friend here. He's always got a smile, so you've got to have yours. Now, this is a very elaborate procedure. You've got to just take it one step at a time. So let's begin. The first step is you're given a function, and the function looks like this, for example, okay, f, and then you're told that the function is defined as follows: f of xy equals something such as 2xy minus 3y squared. So this is our function. With this in place, you are usually also told a point. So the point in our case is 5, 5, and the vector, the direction vector for finding the directional derivative is a equals 4i plus 3j. So these are the key components of the information here. And this is f. It's defined this way. That's the point, 5, 5, and this is the vector a. So the first step is this. You've got to write down a unit vector in the direction of a. So to find a unit vector, all you have to do is take a and divide by its magnitude. So the unit vector here is 4i plus 3j divided by its magnitude, which is this. This is a common 3, 4, so that means the last side is 5. Okay? Squared, which then gives 4i plus 3j over 5. So this is our unit vector. 4i plus 3j over 5. Now write with the thicker end of the marker, but this procedure is so elaborate that it takes up too much space. Okay. So then we have 4i over 5 plus 3/5 j. This is the unit vector. Once this is in place, the next move is this. Evaluate the gradient of the function at the point 5, 5. So let's form the gradient. The gradient consists of the partials put into a vector. So we have the partial with respect to x, which is just 2y. So it's 2yi plus the partial with respect to y. So that's just 2x minus 6y. And once this is done, evaluate the gradient at the point 5, 5. And what we have is 2 times 5i plus 2 times 5 minus 6 times 5j. So now simplify this, which is 10i plus, now 2 times 5 is 10. 10 minus 30 is negative 20. So it's negative 20j, which means now we have 10i minus 20j. So this is the value of the gradient at the point 5, 5. With this in place and with the unit vector, now we simply form the dot product of these two, and then that is interpreted as the directional derivative. So let's do that as the next step. Let's make that big. That should fit. There you are. Okay. So the dot product here of f, the gradient at 5, 5, with the unit vector u is the following. The gradient is 10i minus 20j. You will take the dot product of this with the unit vector, so that's 4/5 I plus 3/5 j. So this now gives this 10 times 4, which is 40. 40 divided by 5 is 8. Okay, so we have 8. Then we have negative 20 times 3/5. That is negative 60 divided by 5, which is negative 12. So 8 minus 12, which is negative 4. There we are. So this negative 4 tells you the directional derivative of the function f at the point 5, in the direction specified by 4i plus 3j. So it's got a very elaborate interpretation, and the symbol that we might use here is, here we go. So this means the directional derivative of the function f at the point 5 along u. So it's negative 4, which means in that direction the function is falling in values because this is just a slope. That's all it is. So it's minus 4, that's a negative slope, so the function is decreasing. So thank you for watching. Keep smiling. We've made it this far to multivariable calculus. That is an achievement in itself.